So now that we have solved R and H calculations, now let's do a few examples on concept questions. Question 1. Can the velocity and acceleration of a projectile ever be perpendicular to each other? 1. Yes, at the top of its motion if it is thrown with a non-zero horizontal component to its initial velocity. Yes, but only if the projectile is thrown vertically upwards. Or 3, no, never. It can never, the velocity and acceleration of a projectile can never be perpendicular to each other. So think about it. What should the answer be? Look at the picture that you have drawn for your projectile motion. That shall help you answer it. The answer is at the top of its motion. So at the top of its motion, the only component that it's going to have is the horizontal for the velocity, and acceleration will always point downwards, which is g. So when you have a motion of a projectile, the horizontal component of the velocity will be this way, whereas the acceleration will be pointing downwards, and they will both be at 90 degrees to each other. Hence, that's the only point where the projectile's velocity and acceleration will be perpendicular to each other. Another concept question. A person standing at an edge of a cliff throws one ball straight up and the other ball straight down with the same initial speed. Example. In a contest to drop a package on a target, one contestant's plane is flying at a constant horizontal velocity of 155 miles per hour at an elevation of 225 meters towards a point directly above the target. At what angle of sight should the package be released in order to strike the target? So this is our question. So let's draw for this problem a picture, right? So that's what is going to be my x coordinate, and that's going to be my y coordinate. Here's where my plane is, here where the object is that it has to hit it, and this is a plane flying this way, and it says it has to go like this in order to hit it, and they say that this is my angle, alpha, that is going to be where my trajectory and my angle is going to be. This is the line of sight, and this is going to be my trajectory. Okay, now the question is, what should alpha be? Okay, so my main concern is to find alpha. In order to find alpha, if I can have y and x, I should be able to find alpha easily by knowing tangent of alpha is going to be equals to x over y. Okay, I'm going to just choose the magnitude of y because I really don't want to worry about whether it's going to be positive x and minus y and minus x. You know, I just don't really want to get into that. So I'm just going to use it that way. But what I do know is that they've given me what this y is. So I can plug that value into here, which is 225, makes my life easy. Correct? However, the question is, I don't know what x is. So somehow I have to find x. So what do we know? We know that in a projectile motion, x equals v naught xt. That means that this x will, whatever this v0x is, it's going to remain the same. Which is awesome because the question gives me that this is going to be 155 kilometers per hour. Right? Times t. Another problem. I don't know what t is. Okay? Now how do I solve that problem? Well, I do know also for projectile motion, y minus y naught is equals to v naught yt minus a half gt squared. If this package is being dropped from the airplane, what is its initial y velocity? Well, absolutely, the initial y velocity is going to be 0, right? And this y is going to be 0 because this is going to be at this point, hopefully hitting it, and minus 225 because that was the height that it had over here. Okay? So this is going to be equals to 1/2 gt squared. Since this is 0, I can ignore it. Minuses cancel. So I will have 225 divided by g times 2 gives me t with a square root. So I can solve this t and come up with 6.78 seconds, which I can plug back into here. But note this is kilometers per hour, so I have to convert this into hours, which I'm going to leave on to you guys to do. Once I have that, I can plug it back into here, solve for my x, and I believe I calculate that x. And then once this x is done, we can plug that back into here and solve for alpha, which is going to be alpha equals tangent inverse of x over 225. Okay? And I'll leave you the details to you guys. Next example. A soccer player kicks a ball at an angle of 36 degrees from the horizontal with an initial speed of 15.5 meters per second. Assuming that the ball moves in a vertical plane, find the time when it reaches a maximum height, find its maximum height, find its time of flight and range, and its vertical velocity when it strikes the ground. In order to do this problem, first of all, let's make a picture. It's going to look remarkably similar to the picture that we had for before. So it's going to have some initial velocity v0 that they tell us with initial speed of 15.5 meters per second. And then it says it has an angle of 36 degrees with the horizontal, right? And assuming that the ball moves in a vertical plane, find the time when it reaches the maximum height. So part A is time to reach h max. Okay? Well, that one's interesting because what do we know? We know that at BFY at maximum height, the velocity in the y direction is equals to 0. So this means I can use equations of motion, which is Vy equals V naught y minus gt, right? First equation of motion. This goes to 0. So what am I left with? I'm left with minus v0y equals minus gt. This gets canceled, and here I can calculate t, which I believe is 0.93 seconds. So once you have that done, then actually make sure that I actually did that correctly, okay? We can go on to part B. Part B says it's maximum height. So now we're looking for h max. Well, what are we supposed to do in here? Well, we could use our equation, the one that we derived in the last one, or we can say that h max equals v0yt minus a half gt squared, which means I can get h max as equals to this one. This is v0y. I cannot put this expression in here, and the reason being that this will have two components, v0x and v0y. v0x will be v0 cosine theta. This will be v0 sine theta. So I plug those values in here, and I get 12.5 meters per second and 9.1 meters per second for both of them. So I can plug in this value in here. It'll be 9.1 meters per second times time, which is 0.93 seconds, which I calculated from here, minus a half, 9.8 meters per second squared times 0.93 squared. And I get H max to come out to be 4.2 meters. So the maximum height that this ball reaches is 4.2 meters. Part C, it says the time of flight and its range. So time of flight, okay? The time of flight, which is t total, is time for the ball to go up in a projectile plus time that it goes down. These two are absolutely equal to each other. The amount of time that a projectile stays in the air is time that it takes to reach this point and time that it takes to reach that point. Okay? So this means it is going to be 2 times 0.93 seconds, which you can solve for that, and it comes out to be 1.86 seconds. Okay? So T total will now be equals to 0.16 seconds. Now for its range. Its range is going to be r, which I can also find by v0xt, which is an expression that I know. This will be v0x, which is, I can put in 12.5 meters per second, times time, which is for the total time that it spends in the air, seconds, which you can calculate it to be, and I calculate it to be 23.3 meters. Okay? But make sure that this is actually correct, okay? I might be off by plugging my numbers in. And part D, it says its vertical velocity when it strikes the ground. So what is its final vertical velocity? Final vertical velocity. Right? Ooh, vertical will be spelled V vertical. Well, what do you think? Remember that one problem we said that the velocity here, all of them are going to be exactly the same? Here? What do you think it should be? If it's the same thing as here and here. Yes, it should be exactly 15.5 meters per second. And the angle should also be 36 degrees. So this angle should match absolutely this angle. Okay? And that's the solution.